All right. Beginning of week 5, we're going to start looking at one of the more common methods for integrating. Okay, so far what we've done is what's known as integration by inspection. All right, so for example, last week on Friday, we did similar questions like this. And the way that we approached it was using what we called inspection. So if I was looking at finding the integral of this value, we started off by thinking, okay, what kind of uh, function would have x plus 4 to the ninth as its derivative? Well, we knew it would have to be this function to at least the 10th power, because when we take the derivative of that, our derivative would be 10 to whatever that function was to the ninth. Okay, but we want it to be just, so in this case that would be x plus 4. All right, but we don't want, when we do the derivative of that, we end up with 10 times x plus 4 to the ninth, and we just want x plus 4 to the ninth. So in order for that to work out, we'd have to have some way of canceling out that 10. So we'd make our original function 1/10. Okay, now when we use the chain rule and derive that, okay, 10 goes out front, so I got 10 over 10 times x plus 4 times the derivative of x plus 4, which is just 1, and that cancels, and we get x plus 4 to the ninth. So the integral, or the antiderivative, would have been to the 10th plus some constant. All right, well, that's integration by inspection. What function has the integrand, remember that we call this the integrand, as its derivative? Okay, now a more systematic way of doing that is to use what's called U substitution. So instead of thinking of, okay, what's going to make x plus 4 to the ninth, what function has that as its derivative, you just make it a little bit simpler. Now, in this case, it's not that much simpler because this is a relatively easy integral by inspection. But what we would do is we'd say, okay, let u equal the quantity x plus 4. All right, now I'm going to do the derivative of that. So the derivative du dx, the derivative of this with respect to x would simply be 1. So I know that du, if I multiply both sides by dx, that du is the same as dx. Now over here what I do is, instead of writing x plus 4, I write u to the ninth, okay, du, and I'm able to take out this dx because it's the same as du. Then we do the integral using our integral rules. So this would be u 10 over 10, okay, plus some constant. Well, then we substitute back in our u value, and we get x plus 4 over 10 plus some constant. And that was the same as what we wrote earlier, except I wrote it as 1/10 x plus 4 to the 10th plus some constant. Okay, so the next one, now we've got a much more involved expression that we want to find the antiderivative to. Okay, so I kind of wrote down some steps here to help guide you through it. Okay, when you have more than one function, you have to be very selective about what you set your u sub to equal. All right, it's okay to sometimes you'll do it incorrectly and you won't get anywhere, and you'll have to come back and redo it. And I'll show you what I mean by that in just a minute here. But typically, you're going to try to take the function that is, in this case, the one that's being raised to the third power. I'm going to let that be my u value. So these are just some tips that you can follow. All right. Tips for selecting u is to consider u could be a function whose derivative, except for the constant, is also the integrand. And we'll go through examples of what each one of these looks like. A function that is an inner function of a composition of functions. That's what we got right here. A function that is raised to the highest power, if there's more than one, and a function that appears in the denominator. All right, so I've got I'm going to let u equal, in this case, the inner function. So I'm going to let u equal x cubed. Okay, now you do the derivative of that. And now you solve this for du. Okay, so I differentiate du, and I want to isolate dx by cross multiplying. So 1 times du equals 3x squared plus 6x dx. Okay, now to solve that for dx, okay, now I'm going to divide by that amount. Okay, so the point here is I wanted to isolate dx. It wasn't a big deal up here because they were the same. All right, now I'm going to rewrite my integral, okay, in terms of u and du. Okay, so back up here, this is going to be the integral All right, now instead of writing out this expression, I'm going to write u to the third. Okay, and instead of writing out dx, that's why we did this right here, I'm going to put in du divided by 3x squared over 6 plus 6x. Now, what that accomplishes is that lets me get rid of the x's because these now cancel out. And now this just becomes the integral of u cubed du, which we know is u to the fourth over 4 plus some constant. Now substitute your u back in. So that's going to go right there. And I end up with x cubed plus 3x squared minus 5 to the fourth divided by 4 plus some constant. All right. So let's take a look at number 3 here. We've got another situation where we have one function, an inner function being raised to a power. So we're going to let that equal our u. All right, so we'll let our u equal this function. So then we take the derivative of that, which equals 2x. And then I rewrite my integral in terms of u and du. Okay, so this part right here that I just did, I'm sorry, is part 2. And now I'm going to rewrite my integral. So this is going to be x, but I'm going to write this as u to the 9th. And instead of writing dx, I'm going to put in du 2x. And it works out that that cancels the x out. So now all I'm integrating is, this would be 1/2 u to the 9th du. We know we can pull that 1/2 out front. Integrate. And then substitute back in our original value of u. And there's our antiderivative. Okay, number 4. All right, u is going to be this inner function. Take my derivative du with respect to x. It's going to be 4x cubed. Solve that for dx. Later on, we're going to substitute that in for dx. All right, now we're going to rewrite our integral using u. And instead of dx, I'm going to put in du divided by 4x cubed. And those cancel. If the x's don't cancel, you can't use u substitution. So you'll find that all of these problems are set up so that the x's are going to cancel. And then I can put my u back in. And there's my antiderivative. Okay. So you think of that as x cubed plus 1 to the 1/2 power. Okay, add 1. And then substitute in your and there's your antiderivative. All right, see you next time.